Hello, everyone. Today I'll be presenting a conference paper titled Slow Fast Networks for Video Recognition. This paper was published in 2020 by researchers at Facebook AI Research, and it introduces a novel architecture for video recognition that takes into account the presence of both slow and fast components in videos. So let's get started. So the authors of this paper are from Facebook AI Research, and they propose, as I already stated, they propose a two-stream architecture comprising a slow pathway and a fast. These pathways capture different aspects of video information and are later used to make the final prediction. And this, as they show in the paper, improves the accuracy of the final prediction. Moving on to the main contributions of this paper, the one of them is the main one is the two-stream architecture, the slow and fast pathway. The slow pathway computes high-level uh, features that remain invariant to slow changes, whereas the fast pathway focuses on motion information, other fast change. Then the fusion of these is the outputs. The fusion of the outputs from these pathways enables a more comprehensive prediction. So the motivation behind this research comes from observation that videos often contain both slow and fast components, but they contribute unequally to recognition tasks. Slow components tend to be invariant across frames, right? For example, the background, while fast components exhibit high variability. As the authors propose an architecture that can effectively capture and utilize slow and fast information separately, which could lead to improved recognition performance. So now let's take a closer look at the architecture proposed in this paper. As depicted in the figure on the slide, the architecture consists of a slow and fast pathway. Both pathways employ a ResNet-like back. Slow pathway operates at a low frame rate of 8 frames per second, while the fast pathway operates at a higher frame rate of 32 frames per second. The fusion of these uh, pathways occurs with channel-wise concatenation operation, or the final output. So the technical details. Now let's dive into some technical details. The authors adopt a ResNet-like backbone for both slow and fast. The slow pathway processes videos at a frame of 8 frames per second, capturing the slow components, while the fast pathway operates at 32 frames per second, capturing the fast components. And the fusion of these pathways is achieved using a channel-wise concatenation operation. So mostly what I stated in the previous slide is uh, basically the technical detail. Moving on to the training strategy employed in the architecture. The authors first pre-train the slow pathway, enabling to capture slow and invariant features effectively. Then fine-tune the entire network using a combination of slow and fast input, allowing the network to leverage both types of information during training. Let's examine the result achieved by slow-fast network. As shown in the figure, the architecture achieves state-of-the-art performance on the kinetics dataset, which is a widely used benchmark for video recognition tasks. These results highlight the effectiveness and efficiency of the proposed architecture. So the implications of this research are significant. The slow-fast network architecture represents a significant advantage or advancement in the field of video recognition. Its ability to capture and utilize both slow and fast components has important implications in various domains, including but not limited to surveillance, autonomous driving, and human-computer interaction. Finally, I'd like to conclude the slow-fast network architecture presented in this paper is a substantial step forward in the field of action recognition. By capturing and utilizing slow and fast information separately, it offers a novel approach to video recognition. This results showcased in the paper demonstrate its effectiveness and efficiency in achieving state-of-the-art performance. Thank you so much for listening.